first three problems here on this website. Okay, here. I like this because we don't need to find the limits of integration because the graphs have already been sketched for us. Okay, to start, okay, we have here the formula in finding the volume of a region bounded by the given curves rotated about a given axis. Okay, we have here, if the axis of rotation is horizontal, so this will be our formula. If the axis of rotation is vertical, we have here also the formula. What does this mean? We have here pi times the integral of f of x squared minus g of x squared dx integrated from a to b. So basically, okay, if we have two functions, okay, for example, this is the first function and this is the second function. Okay, we will call this f of x. We will call this g of x. So if we are going to rotate it above this axis, horizontal axis, above the x-axis, so the formula in finding the area or the volume, I mean, generated when we rotate this region above the x-axis is given by this formula. Okay, actually, if you look at this representations here, the g of x and the f of x, okay, we can say that this one here, we call it the outer function, okay, and the second one here, we call it the inner function. And of course, aside from, okay, treating this as outer and inner function, we can also say that this one here is the outer radius. And this one here, we can also consider this or count this as inner radius. What does it mean? Okay, for example, we are going to draw, okay, on the other side here, the reflection of these two curves, like that. Okay, considering the outer function, okay, because we are rotating about the x-axis, this is the outer function, okay. And if we rotate it about the x-axis, we can generate a disk. And actually, if you look at this, this now becomes the radius of that disk. That's why we can consider this as well as the outer radius. And if we are going to consider the inner function and draw a vertical line here and rotate it about the x-axis, okay, we will have a disk again. And this part here, a rectangle, okay, can now be considered radius. That's why we call it inner radius. So if we are going to find the volume of this region rotated about, okay, the x-axis, it's just the same as, okay, the whole region here, okay, I'm talking about the outer radius or the outer function, okay, rotated about the x-axis, we get a solid there, and we subtract, okay, this volume here generated when we rotate this inner function about the x-axis. So that's why we have the formula there. Okay, in the same manner, okay, if we are going to rotate it, okay, about the y-axis, which is a vertical axis, okay, let's draw it once again here. Okay. Okay, if we rotate it about this axis, the y-axis, okay, noticing here that this function becomes the outer function, okay, and this function here becomes the inner function. Okay, so but you know, because we are rotating about the y-axis, so our function is given by f of y, g of y. Okay, so that it makes sense, so we can start answering problems